So I'm going to start our Flex and Rigid Flex webinar with a story. So let me set the scene for you. This is a real life story from my area of the world, which is the Midwest, and it is fall. And if you can just picture, it is just after dinner on a family farm, and mom's in the house cleaning up after dinner. Dad and son are outside finishing chores, and little girl is also playing in the yard, playing with her new favorite pet, which is a little kitten. And just in the blink of an eye, that little kitten goes racing into the cornfield, and the little girl chases that kitten right on its heels. So I'm going to pause for just a second for those of you that aren't familiar with cornfields in the Midwest in the fall, and let you know that they're very dense, very thick fields. The stalks are about 7 to 8 feet tall, and you can see maybe a row in front of you and a row or two to the sides, and that's really all the visibility that you have in this cornfield. So the dad and son saw the little girl race into that field after the kitty and raced down there as fast as they could. But once they got there, realized just that quickly they could no longer see the little girl. Parents' worst nightmare, right? So dad sends the son into the house. He races in, tells mom what happens. She calls 911 to get local law enforcement to come and start help with the search. At the same time is texting neighbors to come and help. Within a very, very short time, there was local law enforcement, volunteer firefighters, EMS, and a whole bunch of neighbors there to help with the search, and a command center was set up. Now, not that many years ago, the way that this search would have been done would have been people walking in a grid, right, back and forth through the field in a very determined manner, looking for this little girl. But the scene this evening was a little bit different. The command center was able to use the GPS from the tractor that had planted the field to be able to see exactly how that field was laid out. They were able to deploy drones that had thermal imaging capability to help search for the girl. A helicopter was deployed, having that same thermal imaging capability to look on a broader scale. Searchers were connected with the 800 gigahertz radio system and also with their cell phones. And you are probably wondering at this point in time why I am starting out with this story about this little girl in a cornfield on a Flex and Rigid Flex webinar. I was very intentional because I realized that all of the technology that I just mentioned to you from that command center, the GPS, the drones, the helicopter, the cell phones, all contain Flex and Rigid Flex. And for someone who is kind of a Flex geek, I find that very, very cool and interesting. I also think that the PCB industry, or Flex and Rigid Flex within the PCB industry, is going to continue to be a growing segment of our industry, and there are some subtle and important differences that I think people should be aware of as they move into Flex and Rigid Flex technology. So today we're going to talk about why you would use a Flex circuit, Flex materials and best practices, cost considerations. I have a couple of case studies to share, and I'm going to wrap up with real world advice. I went out and asked some of my friends in the industry who've been designing and working with Flex for many years what pieces of information they would like to share with somebody attending this webinar who may be new or considering using Flex and Rigid Flex. So I'm going to breeze really quickly through the Flex circuit benefits because I think most people are pretty aware of them. But just to name a few, space, weight, and packaging is something that is always on top of mind in our industry and will continue to be as we keep trying to add more and more electronics into smaller and lighter weight packaging. And Flex is certainly an enabler to help solve packaging issues and reduce volume and weight. One we don't talk about too often is aesthetics, but that is important as well, especially if the inner workings of the electronics are going to be viewable by the consumer. A sleek piece of polyimide is a good selection over maybe a wire or something like that. And of course, polyimide is also biocompatible. So it's used for biocompatibility reasons, particularly advantageous if you are able to work with gold conductors on polyimide rather than copper conductors. That's something that's new in the industry as well. It obviously facilitates dynamically flexing applications, things like our disk drives or the hinges in our laptops. It's a great heat dissipator, good for thermal management. And then I'm going to lump those last two together. Reduced assembly costs and intrinsically more reliable helps to reduce operator error. So especially if you're looking at complex wire cable harness and able to replace that with a flex circuit, or if you have a rigid board with a bunch of flex ribbons that get hand assembled to it, being able to create a rigid flex and just have kind of a drop in place solution where the design is controlled predominantly with the artwork and the tooling rather than operator, helps eliminate some of the possibility of operator error.